Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is an alpha, beta unsaturated ester, acrylate derivative cyclohexylamide CH is equal to CH group with CO2 The product after reagent A is the corresponding allylic alcohol, CH2O, with the double bond retained. To convert an ester, CO2 to a primary alcohol, CH2O, while preserving the carbon-carbon double bond, we need Lyell-4. NaBH4 is a milder reducing agent that selectively reduces ketones aldehydes but does not efficiently reduce esters under normal conditions. Lyell-4 reduces esters to primary alcohols. Therefore, A is equal to Lyell-4. Moving on to the next step. The allylic alcohol, cyclohexane ring with exocyclic is equal to CH2O, is treated with Main O2. Main O2 is a selective oxidant that oxidizes allylic and benzylic alcohols to the corresponding carbonyl compounds. An allylic primary alcohol, CH2O adjacent to AC is equal to C, is oxidized by Main O2 to an allylic aldehyde, ChO. The double bond is preserved. Therefore, B is equal to cyclohexane ring with exocyclic double bond CH is equal to and substituent ChO aldehyde. And for the final step, A and B use NaBH4, which cannot reduce esters to alcohols efficiently, so A cannot be NaBH4. D uses Lyell-4 correctly but gives CO2H as B, which is incorrect because Main O2 oxidizes primary allylic alcohols to aldehydes, not carboxylic acids. C correctly identifies A is equal to Lyell-4 and B is equal to the allylic aldehyde, ChO. Therefore, the correct answer is C. Therefore, the correct answer is option C.